The final video for section 2.7 is concerned with naming a special class of covalent or molecular compounds that are referred to as acids. We're going to learn how to name two different types of acids. We're going to learn how to name what we call binary acids, and also we're going to learn how to name what are referred to as oxy or sometimes oxo acids. So what are acids? Well, acids are compounds that, when they're dissolved in water, dissociate to form hydrogen ions. So the molecules literally fall apart. So here's an acid. This is hydrochloric acid. We'll learn how we got that name in a little while. And when this guy is dissolved in water, what happens is it falls apart to form hydrogen ions and chloride anions. You can recognize acids from their formula because they always begin with one or more hydrogen atoms, and they always end with the letters AQ as the conditions. Now, whenever an acid is dissolved in water, it's going to form some hydrogen ions and also an anion. And so something to keep in mind is that the size of the charge on the anion can always be determined by the number of hydrogen atoms that are present in the formula of your acid. So if we look here, we have one hydrogen atom in the formula of our acid, so we know that the anion formed has a 1 negative charge. In the formula of this acid, it's called sulfuric acid, we have 2 hydrogen atoms present, so we know that the charge on the anion formed will be a 2 minus. So this can be helpful in trying to identify the name of the anion that is formed when the acid is dissolved in water. So, as I mentioned, acids are compounds that release H+ when they're dissolved in water. In addition to releasing H+, they're always going to release an anion. And how acids are named is on the basis of the anion that is formed. Now, these anions that are formed will have one of 3 endings to them. They'll end in either IDE, they'll end in either NITE, or they'll end in ATE. And depending on the name of the anion, that's going to be how we get to the name of the acid. So you have to be able to name anions. Now, something to keep in mind that makes it really, really simple is that all monatomic anions end in IDE, because that was part of our rules for naming monatomic anions. You don't have to work too hard for that guy. These ones, ITE and ATE, that's what we're going to see when our anion is polyatomic. So these guys, the ides we see for monatomics and polyatomics, but we never see ites and eights for monatomics. So if the anion that is formed when the acid is dissociated in water, dissolved in water, ends in IDE, then this is how we name the acid. We begin it with prefix, we write the stem or root name of the anion, and then we finish that off with the letters IC and add the word acid. So this guy here, the anion form ends in IDE, so we start with hydro, and then we put the stem name of the anion, chlor, then the letters IC, and finally the word acid. So hydro, that's part A of the naming process. Chlor, that's part B. The ic, that's part C. And then finally we add the word acid. So it's a non-trivial process, but you can't begin until you've named this anion. Okay. When we have an oxoacid, we're going to have one of these oxo or oxy anions formed. So we're going to need a table of the names and formulas of these oxy or oxo anions. So this is an acid here. We get one H+ and we get an NO3- anion forming. So we're going to begin by naming the anion. This is the nitrate anion, and we see that it ends in the syllable ate. Okay, and all anions, if the anion ends in the syllable ate, then the acid is named as a ic acid. So that's good because there's nothing at the front. So this just becomes nitric acid, right? Nitric acid. Very, very easy going. Now, in this case, HNO2, it dissociates to form H plus and NO2 minus. We name this anion, and it is the nitrite anion. So we're paying attention to the last three letters there. And our rule that we have is all ites, all acids that form ite anions are named as us acids. So this is going to become nitrous acid, right? So we have ites become hydro, then the stem name ic acid. Ates become ic acids, and then finally ites become us acids. So we've got three rules for naming these guys. Now we do need to be able to name the anions in order to be able to apply these rules. There is another class of acids that you will hear about. These are called carboxylic acids, and very common in organic chemistry to be talking about carboxylic acids. You can recognize these guys from their formulas because they all contain this group of atoms where we have one carbon, two oxygens, and one hydrogen. It's commonly written like this, COOH. These are these carboxylic acids. These are what your amino acids are all carboxylic acids. So there are many of them in what we call natural products. We don't have to learn how to name them, but you might see these guys and be expected to recognize them from their formulas as acids. Okay, so that concludes this section on the naming of acids. We looked at the naming of binary acids. They're going to be your hydroic acids, and then we looked at the naming of oxy acids. They're going to be your ic acids and your us acids. It's all about being able to recognize what anion you have you have present. Now, I should point out that there is a worksheet. It's about 12 pages long, that's been posted in the modules that goes through the naming of all three classes of compounds, and I highly recommend that you give that a go.